All right, good afternoon, everybody.
Good afternoon.
We are going to continue to study chapter 15 this week with a concentration on using nets to solve different things like surface area and surface shape based on what kind of features each prism has, each pyramid has. So I'm going to be giving you a couple of items. I put this today on the Google Classroom post. This area formulas cheat sheet. And this is going to be really useful for you to have on hand this week. You will be able to use this sheet on your assessment, which is on Friday. But you need to know how to use it. So I'm going to teach you how to use these area formulas this week when calculating surface area. So if the object that you are finding the area of is a flat shape, it's not a big deal. You just find the shape you have and use the formula given and plug in the values that correspond to the diagram here, right? But it gets a little bit more detailed when the thing you're calculating the surface area of is a three-dimensional object. You knew from our work the past couple days with our net monsters that when you unfold a three-dimensional shape, there are several shapes that construct it as a whole, right? So to calculate the surface area of a prism or a pyramid, you would need to unfold that shape, find the area of each shape, and then combine them by adding their total area. So that's what we're going to be working on over the next 3 days. And you'll have an assessment on Friday that basically tests your knowledge on identifying prisms and pyramids, calculating the surface area, calculating volume of rectangular prisms. So that sort of thing, all right? So throughout the week, we will continue to practice with this skill set. People at home, I haven't posted this paper to you yet, but we will tomorrow. It will be on your posting. But today, this one is there, right? This one's there today. So this is the surface area or area cheat sheet for all the different polygons and that we're going to be using over the week. Now, a circle is not a polygon, right? Because it has curved sides. But everything else on this page is. We're going to look right now, and I'm going to invite you now to open your workbook to page, keep this next to you, 255. It will look like this. 255. So we're going to read this opening paragraph together. I really feel like this chunk of information is actually really helpful. Sometimes the thing your book introduces a topic on, I think, are a little odd. They hit you right with an example instead of with the whole context. But today they did a good job at this. Are you ready? Let's read this page 255. That's where we are. Ready? Let's read this together. Surface area, I'll read it. You listen really well. Surface area is the total area of a surface of a three-dimensional figure. A prism is a three-dimensional figure that has two polygons as identical pair bases joined by rectangular faces. Remember we talked about that last week, that a prism has two identical bases surrounded by what? Rectangles, right? And a triangular prism, though, has bases in the shape of a triangle, and they're connected with rectangles. In a rectangular prism, all of the faces that join the bases of the prism are rectangles. So this focus on 15.2 is about prisms, but turn the page. What's on the next page? Surface area of pyramids. So here we go. A pyramid is a three-dimensional figure that has one polygon for the base, and then what's connecting it this time? Triangles are connecting at this time, and they connect with a common vertex at the top of it, right? This one that's featured on your paper here happens to have a square base, and we call this one a rectangular pyramid, or we can just call it a pyramid, because a rectangular pyramid is like the standard shape of a pyramid. What if it had a triangle base? What would you call it? Triangular pyramid, yep. What if it had a hexagon base? We would call it hexagonal pyramid. What if it had a octagon base? Octagonal pyramid. Good job. So how we're going to go about our work on both 255 and 257 is we're going to use our understanding of a net, unfold it, and then calculate the surface area of each of these little mini sections and combine them for a total surface area. Now, what do you think about this? Do I have to find the area of A, B, C, D, E, and F separately, or are there some shortcuts I could take? What shortcuts? What shortcuts could you take? And your hint would be right here in this section here. So go ahead and maybe read that section and answer my question. Are there any shortcuts I can take? Read 255. Anyone find some shortcuts yet? If I have to find the surface area of A, B, C, D, E, and F, that's going to take a while. What shortcut did you uncover? Okay. By what? You have to give me a little bit more info than that.
Like B and E are about the same size, so you would do B times 2.
Okay. So Ava suggesting that B and D are exactly the same rectangle. So if I find the area of one of those rectangles, all I have to do is multiply it by 2 in order to combine their areas. Do you agree with that? Do you see any other congruent rectangle faces on here? What do you see, Allie? C and F are congruent, and they take the same size and the same shape. They have the same dimensions. So I only have to find the area of them once and then multiply it by 2. Do you think A and E are the same? Do you remember that when we were coding this last week, we put, I think, 1 and 1, 2 and 2, 3 and 3. Do you remember we did that last week? So you can use numbers, you can use letters. I would think that maybe letters would be smarter in this case because you won't confuse them with the dimension labels. Okay? So if we were finding the area of this entire shape unfolded, look at how they've organized it. Area A, area B, area C, area D, area E, area F. They all are rectangles. So they all follow the length times width, length times width, length times width of each individual rectangle. We see the duplicates. Here is A and E. They have the same, right? So we just write it down. Then B and D have the same, so we write it down. And C and F have the same dimension, so we just write it down next to each other. Want to try unfolding one?
No.
What?
No.
Sure, Mrs. Moore?
Sure.
Yeah, I'd love to try unfolding one. Yeah. So I'm looking at 1, 2, and 3. Those are the ones I'm hoping to accomplish today. 1, 2, and 3 on both 255, 257. Let's give it a try. Maybe we'll toggle between the 55, 57, 55, 57, so that we get a taste of both prisms and pyramids at the same time, okay? I asked you to bring your notebook today because I know there's not enough room to unfold these in your notebook. So we're gonna look at each prism or each pyramid. We're going to unfold it and draw it as a net on our paper. So open your notebook to the next kind of clean page. And I'm just going to get a blank paper up here, okay? Number 1 on page 255. That's the one we're going to do first. And I'm going to give an attempt to writing on the board right now. Will you see if it will write before I go up there? And all right. Well,
Really uncalibrated.
okay. I'll give that a try. Yes, ma'am.
I think I left my notebook at home when I had COVID.
Grab a scrap sheet of blue slate. We're going to try calibrating here real quick so that we have a nice. All right, that might work a little better. Everyone ready? So I'm looking first at 255, number 1. That's better. If you're in the classroom and I'm blocking you, please just mention it because I can't tell who can see and who can't see. So this is what we see three-dimensionally. We have, is this first of all a pyramid or a prism, boys and girls? The prism. The bases are rectangles and they're connected with rectangles all around. There are other dimensions. So we're given 3 dimensions here. When we unfold this net, and if you help unfolding this net, then I suggest you flip back to 15.1. Do you see that drawing of how to unfold a rectangular prism? No, I don't mind how you arrange it on your page as long as you have something that looks like a net here. A rectangular prism net. Do you have that on your notebook? Let's go, write it down. So if you're looking at my drawing, it kind of looks like I tipped this prism over onto its side and then just started unrolling it or unwrapping it, okay? Now, if you put your prism facing, like your net facing the other way, it's okay, as long as you have how many rectangular faces? 6, right? 3 congruent pairs. So I'm gonna first label them. A and A go together. B, oh, not this again. B and B go together. C and C go together. And in order to find the surface area of each of those pieces, we're going to have to transfer some of these dimensions to our drawing of the net, okay? So what would you label this length as? What number would you assign to it? 31, 22, or 13? 31. Okay, so on this surface right here, please transfer the dimension 31, and without writing it, you know it applies to here and here and here and here, right? You know it applies to all those other sections. You don't have to write it on every single spot, but maybe you write it one more time on the bottom just to remind you that 31 inches is that length throughout every single line that happens on this net. Got it? All right, what would you label this side to be? What do you think? 22? Okay, yeah, 22. So if this is 22 inches, what would this side over here be? it would be 22 as well, right? Because opposite sides in a rectangle are what? Congruent, they're the same, yes. So what other rectangle, the one that is labeled the same as this one's an A rectangle. So which other rectangle has the same dimensions? The other A one, right? So this one has the same dimensions. If 22 is the length from here to here, then would you agree 22 is also the length from here to here? Yeah, so let's go and label a little bit more. What do you think 13 is? Want to come point it out? Point out, where would 13 be? Yep. So yes, from there to there, yes, from there to there would be 13, right here. Right here, and it would actually be here too. These would both be 13s. So we have a 13, and a 13, 13, right? This one's 13 as well. So just getting our minds kind of situated with the different dimensions. Don't feel like you're over labeling it. You can label the entire figure as much as you need to in order to calculate the area, because the ultimate goal is to what? Calculate the surface area of the whole shape. So I think we have enough information now to do it. Can I erase this original prism so I have some space to write? Okay. All right, here we go. So the area of shape A is going to be calculated using length times width. So what is the length and what is the width of shape A, boys and girls? 31 times 22. Good, and we can calculate that later. We'll leave it alone. And we know that we need two of them, right? Because this one and this one are what? Congruent, right? So we will find the area of that and then actually have the second copy of it. What would be the area of shape B? What's length times width for shape B? What's length times width for shape B? What are the dimensions here? Let's look at shape B. 13 and 31, okay. And we will go calculate that in a moment. We know we're going to need another one of them because there's two. All right, how about the area of shape C? What are the dimensions for shape C? I'm going to kind of trace it here for you. Can you see what are the dimensions of shape C? 13 times 22. We're going to calculate that, and then we're going to find a second copy of it and then find the answer to that. Okay, if anyone has a calculator, you're welcome to pop that out right now. What's 31 times 22, or calculate it real quick in your head. 31 times 22. 682.
Yeah.
682. All right, so that means this one's 682. What's 13 times 31? You have to talk more clearly, guys.
400. 400.
And what's the area of 13 times 22?
286.
So how do I find the total area of this shape? What do I do? Add them up. Okay, add them up. 682 plus 682 plus 403 plus 403 plus 286 plus 286. How would you possibly do this in your head? Give me my total area.
2,742.
Can I see that number? 2742, boys and girls?
Yep.
So total area is 2742. Now give me my units. What are the units? Inches. How many dimensions is area dealing with?
Cube.
So this is kind of interesting. We know we took a three-dimensional figure, but we turned it into something what? Two-dimensional. It's flat. So if we're only looking at 2 dimensions, then we give it a squared units here. We're going to use it to the second power. All right, that was number 1. Whew. See how long one problem takes?
That's one problem.
That's one problem.
This is worth a practice.
It's not worth the practice. The next one will be easy, I promise you. Okay, so for the first one, we only used the formula for a rectangle, right? Length times width. When we use the formula for a triangle there, remind yourself, what is the formula for a triangle? It's base times height, but then what? We're dividing by 2, yeah. Because a triangle is literally half of its rectangle counterpart. Okay, let's go to 2. You can just write this continue on your notebook. I'm gonna go to 257 now. And I'm gonna try number 1 on 257, okay? 257, number 1. And you'll notice that what type of shape is there waiting for us. I'm trying my best here, drawing a pyramid.
Are we on one or the other page?
Yes, sir.
We didn't use 1 through 6 on both pages.
Nope, just the first page today. This is 257. All right. So step 1 is to turn it into a net, right? Let's make it flat. Let's uncurl it. And since this is a pyramid, we know a pyramid has one base and then triangles span out from that one base. What is the base here? It's a square. Okay, so let's draw a square first. What dimensions would you give that square? I mean, you can unroll it all the way, or you can add your dimensions as you go. But what would the dimensions that carry along the length of these squares be? What would the numbers labeling that be? 2.5, right? So let's label them maybe and try that approach, label as we go. 2.5, 2.5. And we know, Santo, did you want to help us with creating the net? What's your question?
I was just wondering if I could go use the restroom real quick. You know.
We're gonna keep going, but yeah, go ahead. We're fanning out some triangles from each of those spaces of the square, right? Can you imagine how folding them back up would make a pyramid? Who chose to make a pyramid when we did our net monster families? Anyone do a pyramid like this? Okay. Now help me with the dimensions here. We know the base is 2.5, right? But the height is going to help us with the calculation of a triangle, right? And the height of each of these triangles is what? 3 yards. So we know each of them is 3. We don't even need to write it down. Okay? So how many shapes do I have to calculate the area of? There's 5 shapes, right? But are any of them duplicates? Yes. Yeah, so that can save me time, right? This shape is all by itself, right? There's only one of these, so I'll call that shape A. What about the triangles? Are they all the same or are some of them different? What do you think? Let's prove it. So the bases are all 2.5 because I'm dealing with a square here. The bases are all 2.5. Are the heights all 3? Yes, they're all 3. So these are all equally sized. This one is equal to this one. This one is equal to this one, right? They're all equal. So each one of these I'll call B. How many B's do I need? 4. So I'm going to find the answer to B and just multiply it times 4 and then add it to what I got for A. Doesn't that make sense? Yeah. Then I'm not doing the same work over and over and over again. All right. What area formula do I need to calculate the area of the square? What area formula for a square? Length times width, right? So what is the length times the width for section A? What's the length? What's the width? 2.5 times 2.5. And what does that get us? 2.5 times 2.5 is, no, I didn't say add, I said times, right? 6.25. All right. Now, what is the area for B? What's the area for B? We have to use our area formula. Let's see on our sheet, what does it say? To calculate the area of a triangle, I need to do base times height, but half of that, divided by 2. So what's base times height?
2.5.
2.5 times 3.
Divided by 2.
What's 2.5 times 3?
72.
Okay, and then divided by 2, what do I get? 3.75. Okay, so that's one of them. How many of those do I need? What would 4 of those be? What's 3.75 times 4? 15? Okay, so 15 added to the 6.25 that I had from the square. Add some placeholder zeros if you'd like to help you with the adding. And what do we have all together?
More. Hold it back.
What's that? I can't see.
I can do it.
If you add them all together, what do you get as a grand total of area? 21.25? Okay, what are my units? Yards. And is this 3-dimensional or is it flat? It's flat, so I use 2 dimensions here. All right, so we did a prism, we did a pyramid. Let's try and get one more of each in before you have to do your homework, okay? Let's try and get one more of each. Or at least one more of the ones you have to do for homework tonight, okay? So I'm going back to 255. And this guy has triangles and rectangles in it. 255. I'm on number 2 now. And just to save us some time, I don't need to draw out all of the dimensions here, right? You can use what you see on your workbook to help you, okay? Let's unroll it. So we have 2 bases that are what type of shape? What are the bases? They are both they are triangles. And how many rectangles would connect 2 triangles? 3. Yeah, that's right. So use your cheat sheet kind of on 15.1. It shows you how to draw a triangular pyramid. If you flip back to 15.1, you can see how to draw a triangular prism like this. How many rectangles would you need? You said 3. And we're going to just put those triangles off the side of any one of the rectangles. So unroll it. Now let's start to calculate the area of each of those by transferring dimensions over to our page, okay? I'm going to check on the chat room here. All right, let's transfer some dimensions. What dimensions would belong up here along this top surface? What's the length of that rectangular piece? 16.5 centimeters. And that would be the same here, and that would be the same here, and that would be the same here. Do you agree? We don't have to write it in all 4 places. You can write it in one place as long as you can access that information when you need it, okay? All right, I'm gonna transfer it just down to the bottom. All right, what else do we know? What else do we know? Do we know the height of the rectangle or the height of this one right here? Do we know that length? 8.5. So 8.5 is the height of this right here. That's the height of this triangle, 8.5. And this one at 8.5.
Are we trying to find the height of like?
Yes, I want to know what is it from here to here. So the length of one of those rectangular faces. I'm hearing 10. Okay. So 10 would be the base of this rectangle as well. Do you agree? Okay. So we can tell that all 3 of these rectangles take on the same form, right? 10, 10, 10. So instead of multiplying them each separately, could we say, well, this one is going to be equal to this one, is going to be equal to this one. Find it once and then multiply that answer times what? 3. Okay, so we're gonna have 3 A shapes. And what about the triangles? We're gonna have 2 that I'm gonna call B, because they are the same shape. So we're gonna have 2 B's. Could you go ahead and calculate each of those sections for me? Calculate A, get an answer, multiply it times 3. Calculate B, get an answer, multiply it times 2. Okay.
So you calculate it, B, and then multiply it by.
Yep, because there are 2 triangles. Um, 8.5.
Wait, for the triangles, wouldn't you have to do 10 times 8 and you should divide it by 2? So then we have to multiply by
So
2
those
also?
cancel each other out, right? So you're noticing that some of your skill set from fractions is kind of coming into play here, where if you know you have to multiply it times 2 and then divide it by 2, they're gonna eliminate each other anyway. So you can just treat that as, what is 8.5 times 10? Slide the decimal once, what would you get for 8.5 times 10? 85, good. So what if you did 16.5 times 10? Slide the decimal once, right? That would be 165. What's 165 times 3? Anyone get that answer? Okay, let's combine these two kind of partial areas. What'd you get? You should have this all on your paper here. What's 495 plus 85? So the total area, 580. Give me my dimensions here. What kind of dimensions? Centimeters? Centimeters squared. Okay. All right, so today only you're working on the prism side. You're working on the prism side. Oh. 1 through 6. So you're gonna have to use a net, unfold it, draw the figure as it looks when it's unfolded, and then calculate the surface area of those smaller sections. Feel free to use 15.1 and your cheat sheets to help you with some of those formulas, but it looks like only rectangles and then one of them has a triangle involved. Okay. We'll work on this more tomorrow. So don't worry, we're gonna keep building confidence and accuracy with it tomorrow and the next day. Yep. I don't mind if you do it on loose leaf or in your notebook. I don't care. Yes. Yes, please draw the nets for all the figures as you work. All right, everybody, I'm gonna head out to my next class. Yes, Jacob. Is she coming up after school? Okay. All right, thank you.